Hey guys, this one is going to be about 8.2, so let me bring up the PowerPoint. Here we go. Okay. So we talked about normal distribution last time. Now we're going to talk about students' t distribution. And you use this when we're going to talk about chapter 10.3. It is different from the normal distribution, and it has actually different rules and everything. So let's talk about it and see how it is. Okay, so the properties of a t-distribution. Okay, the curve is symmetric and bell-shaped. Its center above 0. It's completely defined by the number of degrees of freedom, df. df means degrees of freedom, and we're going to go into that in just a minute. The total area under the t-distribution curve equals 1. The x-axis is a horizontal asymptote for the t-distribution curve, which means those tails, those lines are going to get really close to the horizontal axis, but they're never going to touch. Let's see. Find the value of t, 0.025, for the t-distribution with 25 degrees of freedom. Okay, it's telling us our degrees of freedom. So we have to look in a different table. So if you have the hardcover of the book, if you go to the back cover and then look at the page adjacent to that, you're going to see table C, critical values of t. So we know that our degrees of freedom are 25, and we know that it's an area in the right tail of 0.25. Okay. Remember when we were looking at normal distribution, if we were using the table, it always defaulted to the left. This table is different. It defaults to the right. So you're going to look for area under one tail, because there's 1 and 2 tails. So we're going to look at 0.025, and we're going to go down and look at the degrees of freedom as 25, as it said. So we get 2.060 as our area. Okay? So let's do this one. Find the value of t for the t-distribution with 17 degrees of freedom, such that the area under the curve to the right of t is 0.10. Okay, so we're going to look at it. Degrees of freedom is 17. The area is 0.10. So what we're saying now is the area under the curve is 0.10. That means that the alpha is 0.10. So we're going to look at our distribution for 17 degrees. So if we look at the column, we're going to see that the amount is 1.333. So if you look at it, area for one tail, 0.100. We go down to degrees of 17, we see 1.333. So what we're doing basically for there is you're doing it the exact same way as we did before. Okay? So it's 1.333. So that's our area. All right, so now we're going to the left. Those first two examples were to the right. Now we're going to the left. Find the value of t for the t-distribution with 11 degrees of freedom, such that the area under the curve to the left is 0.05. Okay, degrees of freedom are 11. The area is 0.05. So we look here. Because it's symmetric, we can look up the t value for an area of 0.05 to the right of the t. So what you're going to do is, remember, the table is different from the normal distribution. You'll look it up in the table, and you get 1.796, because the area was 0.0050, and the degrees of freedom were 11. But then from there, you're going to flip the sign, because instead of going to the right, you're going to the left. You can also do this with your calculator. If you go second bar, number 4 is inverse t. So if you put that in, you're going to put the area to the left and then the degrees of freedom. So it's going to be 0.05, comma, 11. Close the parentheses, and what do you get? You get negative 1.795888. All right, now see this, that you cannot use it for areas to the right, only areas to the left. Okay? And note the negative sign. When you're finding areas to the left, they're going to be negative. When they're going to the right, they're going to be positive. Okay, so this is given 2 tails. So Find the value of the t-distribution with 7 degrees of freedom such that the area to the left of negative t plus the area to the right of 0.02 see as it's shown in the picture. So your degrees of freedom are 7. Okay, so we know we have 2 tails. And we know the total area is 0.02. So to get the individual areas, we have to divide by 2. So we're going to do that and look it up in the table. So what we're going to do is we're going to do area under 2 tails is 0.02. And our table does that, which is great. And our degrees of freedom is 7. So it's 2.998. So when we look at that, though, all you had to do was look that up that way. Or if you want to use the calculator, because you can find the area to the left to find the area to the right. So go alpha divided by 2, so it's 0.02 divided by 2 gives you 0.01. So then you're going to put that in your calculator. You go second, bar, 4, so it's going to be 0.01, comma, 7, parentheses, and you get negative 2.997. So that is the area to the left. To get the area negative t to the left is negative 2.998. Positive t to the right is 2.998 because the table's symmetric. All right, find the critical value of the t for the t-distribution with 29 degrees of freedom such that the area between negative t and t is 99%. So how could we figure that out? Since 99% of the area under the curve is in the middle, that leaves only 1%, or 0.01 of the area in the 2 tails. Since the t-distribution is 29 degrees of freedom, look across the row at degrees of freedom equal 29, and then down the column for an area in the tails of 0.010. Then you get t equals 2.756. So let's look at that. Okay, so I know my 2-tailed area is 0.010. And my degrees of freedom are 29, so I get 2.756. All right, we can do it with a calculator again. Remember, we have to divide that area under the tails. So 0.01 divided by 2. And somebody might be asking, well, where did you get that 0.01? That is the decimal form of 1%. That's all we did. We divided it by 2, and we get 0.005. So if you do second, bar, 4, and you do 0.005, comma, and 29, comma, you get negative 2.756. And if you want the positive value, just ignore the negative sign since the t-distribution is symmetric. Okay, so let's do this. Find the critical t-value for a 95% confidence interval using the t-distribution with 29 degrees of freedom. Okay, we're doing it the exact same way. Okay, so practice with that. And let me know if you have any questions. And remember, you can only use the calculator if you're going to the left. If you're going to the right, you can't really use it. So I hope this has helped, and talk to you later. Bye.